Welcome back to Backspace Academy. In this lecture on Identity and Access Management, or AWS IAM for short, I'll talk about the concept of a shared responsibility, how we are responsible for what we put on AWS's infrastructure. I'll talk about the IAM service and how we can create users and how we can create groups of users, and also how we can create roles that will grant the least privilege to a user or even a resource, grant least privilege access to our resources. And I'll talk about identity federation, which can be used to authenticate or externally authenticate users or resources that are external to the AWS infrastructure. So AWS has a security shared responsibility, a shared responsibility model of how security should work, with the interaction between the customer's responsibility and AWS's responsibility. So we can see there down at the bottom level, we have AWS responsible for security of the AWS infrastructure. So they have compute services such as EC2. We have storage such as S3, and we have our edge locations, our regions, our availability zones. So AWS will do everything that they possibly can to ensure that that is secure. But they're not responsible for what we put on their infrastructure. So our customer responsibility is responsibility for security in the cloud, what we put in the cloud, and AWS is responsible for security of the cloud. So that could be our customer data and access to that and confidentiality of that. It could be making sure that our platform, our applications are updated, making sure that we have our identity and access management properly managed. Do we have multi-factor authentication going on, and this sort of thing? So these are the kind of things that we, as a customer, we need to make sure that we make sure that they are secure, and AWS will be responsible for their nuts and bolts and tin and making sure that that is secure. So just looking there, we can see that what is managed by Amazon Web Services there in orange, and what is managed by AWS customers in blue. We can also see that there are different concepts of this shared responsibility model. So we have a shared responsibility model for infrastructure services, and we also have one for container services, and we also have one for abstracted services, and we'll talk about that in the next slide. So again, we can see that there's customer data, and we have the operating system, and down there for infrastructure services, we have there AWS is responsible for those infrastructure services that are going to be provided. So what does that look like for the model for infrastructure services? So there we can see our foundation services, our compute storage database, and again our customer data. And so that can be Amazon EC2 and other services like our EBS, our auto scaling, our Amazon VPC. We need to make sure that that is secure from our perspective. So we control the operating system, and we can configure and operate identity and access management. So we need to make sure that we use that wisely and responsibly. When we look at container services, now a container service is one that we don't actually control what goes on from the very low level. It's not like an EC2 instance where we're basically defining the AMI, we're defining the image, and we're launching it from a very low level. We talk about Amazon RDS, for example. It's a container service. So AWS is going to look after a lot of the patching of the operating system and all this sort of stuff that we would patching of the database engine and that sort of thing. And that's stuff that we would normally do in an EC2 instance. If we were hosting, for example, an Oracle server, then we would look after making sure that our Oracle database software is up to date. Amazon EMR, as opposed to having Hadoop running on EC2, having the Amazon EMR service, we could have a look at AWS Elastic Beanstalk, again is a container service. And this is where AWS, they provide a managed service. So they're going to take a little bit more responsibility than they would in purely an infrastructure service provision. So we're responsible for the network controls, firewall rules. We're also responsible for platform level security. That is separate from IAM. So we might have database access that we need to manage within the actual database software itself. The next one we look at is abstracted services, and they're an even higher level than container services. So that's where we have a service and we don't particularly know what is behind that service. For example, Amazon S3, we know there's obviously going to be some file servers there that are interacting with this AWS S3 service, but we don't exactly know much about the nuts and bolts of how the Amazon S3 service works. So these kind of abstracted services, so they're high-level storage, database and messaging services like S3, Glacier, DynamoDB, Lambda. We're running a function, but we don't really know much about how AWS provisions their infrastructure to run that function. Amazon SQS and SES are examples again of abstracted services. So AWS manages the underlying service components or the operating system on which they reside. So we again are responsible for our data that we put on Amazon S3. We're responsible for client-side data encryption and data integrity and authentication. AWS, they're going to be responsible for server-side encryption on Amazon S3. They're going to be responsible for network traffic protection across Amazon S3. We're not going to take responsibility for that. AWS will take responsibility for that as an abstracted service. So what is actually IAM? So IAM is a web service that allows you to securely control individual and group access to your AWS resources. You can create and manage user identities or IAM users and grant permissions for those users. The features of IAM, it allows shared access to your AWS account. We can have multiple users and manage those multiple users accessing our account. It has very granular permissions. We can get very fine detail around what users can or can't do or can't access with our infrastructure. It provides secure access to AWS resources for applications that run on EC2. If we have an EC2 instance running on our infrastructure and that needs to access other resources within our infrastructure, we can set up a role to do that. There is identity federation to grant permissions for users outside of AWS. It is also payment card industry or PCI, data security standard, DSS compliant. It provides access log auditing using CloudTrail, and it's eventually consistent. So as a global service within Amazon Web Services, the IAM service needs to be updated across that global infrastructure. So if we make a change to IAM, it's going to take a certain amount of time for that change to be propagated across the global infrastructure. That's not going to be a big amount of time. It might be 5 or 10 seconds or so, but it will take a certain amount of time for that to propagate across. So if you're a developer and you're just expecting to make a change and that change has occurred and you trot along and do your next code, then you're going to have to make sure that you're not relying upon that to be instantly effective, because it won't be. It'll be eventually consistent. IAM's free to use, so go for your life and use it as much as possible. It provides good security, good granular permissions. Make sure you use it as much as possible and it won't cost you a thing. So we have IAM policies. And so by default, users can't access anything in your account. So if you create a user, they can log in, but they can't access anything. So you grant permissions through policies that define the effect, actions, resources, and optionally conditions around that access. So we can see there we've got just a sample IAM policy. And so we've got an effect, which is we're going to allow DynamoDB access to a resource, or we're going to allow access to a DynamoDB table with that ARN there, with that Amazon resource number there. Users, they represent a person, but they can also represent a service that needs to access your account. It consists of a name and a set of credentials. So users are identified by a friendly name, for example, Bill. They can be defined by the user's ARN, so Amazon resource name, and that would look like that. And we can see here ARN :AWS IAM, and then there's 2 colons. So we don't, this is a global service, so we don't define a region. So it'll have 2 colons there. Then we have the account ID without hyphens, and then :user, and then a slash, and then the user friendly name after that. So you need to understand what an ARN looks like for a user. It may come up on the exam. We can also use a unique identifier, and that is returned only when you use the API or the software development kits, the tools for Windows PowerShell, or the AWS command line interface to create the user. So when you create that user, you will get, as a return response, if it's successful, you will get the unique identifier for that user. So you can actually use that unique identifier to identify a user using the API or SDK or CLI or PowerShell tools. Credentials that can be associated to a user. So we can have a console password, and the user will have a URL link to the console, and they will put their password in, their username and password, to access your account. You can have access keys, which will be an access key ID and a secret access key, and there's a maximum of 2 of those per user. We can have SSH keys for use with AWS Code Commit, and we can also have server certificates for identifying a user. Very, very important. Never use root user to access resources unless absolutely essential, and there are very, very few occasions where it is essential that you use root access to your AWS resources. Always create admin users with the required permissions to access your resources. Never give anyone root access to your resources, and always enable multi-factor authentication on that root user, and store that root user information somewhere safe. So groups are collections of IAM users, and when users are put into a group, they assume the permissions that are assigned to that group. So if they go into the admins group, we don't have to individually give, for example, they're Bob and Susan, we don't have to individually give them access. As soon as we put them into the group admins, they're going to have all of the rights and access to that is defined with an admin group. So users can belong to multiple groups, but groups can only contain users and they cannot be nested. So you can't have groups of groups. There's a maximum of 100 groups per account. Roles are very important. They define permissions, or they are defined permissions that can be assumed by a user or resources. So they're different to groups. They also allow EC2 instances to access other EC2 resources. So if you've got a web server that needs to access a database, for example, the RDS server, you can create a role for that EC2 instance to do that. And at the same time, keeping your database secure from any internet traffic. So roles grant users can be used to grant users in one AWS account access to resources in another AWS account. So it doesn't have to be within the same AWS account. You can actually do cross-account access. So scenarios that we would use a role, they can be used to allow users to temporarily assume a role with least privilege access to critical resources. They also can be used for an application that's running on an EC2 instance to access AWS resources. Identity federation, we can use an IAM role to specify permissions for externally identified or federated users. So what that means is that we can build a trust relationship between a service that is external from AWS to AWS. So we can have a trust relationship built up there between that, and we can use that, once that has been established, we can use that external service to authenticate users, and then we can use that authentication or that federation of that user to that federated user can be granted temporary credentials to access our AWS account. Where this is important, we have a maximum of 5,000 users per IAM users per account. So if we have an organization that has more than 5,000 users, we have a problem. If we have a web application that has 5 million users, we have a problem. So identity federation enables us to create an unlimited amount of temporary credentials for users to access our AWS account. And we can do that safely by having a trust relationship between our organization. Our organization can validate or authenticate those users through our, for example, our LDAP service, our directory service. Or we could use a third-party identity provider. So the methods of federating users, the gold standard here is Amazon Cognito, that allows for developer authenticated identities. So we can have our application authenticate the identity. It allows for guest access with limited permissions there. Or we can use a public identity service provider. So a public identity service provider, we don't necessarily have to use Amazon Cognito. We can actually use a public identity service provider on its own, or we can use it in combination with Amazon Cognito, or an OpenID Connect provider. So that an example of those could be Facebook. So we could log in with Facebook or Google or Amazon credentials. So using your Facebook login password and username for your Facebook account, you can log in through Facebook and get access, temporary access to an AWS account. We can have identity provider software packages that we can have on our application that support SAML2 or security assertion markup language. So if we have that software package and we can build a trust relationship between our application and AWS, and we can use that identity provider software package to authenticate our users. We can also create a custom identity broker application that authenticates our users. For example, we can create an application with our enterprise's LDAP or Active Directory service, if we're talking about Microsoft services. And then the application then assumes temporary credentials on behalf of that user. If we're going to go down that road, though, we need to make sure that we understand that there is another option, and probably a preferred option if we're going to use Active Directory, is that there is an AWS Active Directory services or AWS Directory service for Active Directory. And we can use this as our on-premise and AWS directory service for AWS access. So that's probably a preferred option, but we can also create a custom identity broker application ourselves if we need to. So that brings us to the end of our lecture on IAM. We'll have another hands-on lecture following this, and also there will be labs that involve IAM as well. So I look forward to seeing you in those.